All right, so we're back again. The last time that we were in our previous video, we created a function for parsing the HTTP version. Um, the final piece of information that we need to be able to extract out of that first line of a request, if we take a look at all these samples we have here, is the actual resource. For example, if we want to get the index page, or another thing that comes along with the resource, the URI, as I'll keep referring to it, is potentially additional parameters that come along with it, also known as query strings, a term which I hate, by the way, but I didn't make these up. So a query string is set off by a question mark character, followed by any number, asterisk, any number of key value pairs, where we have key 1, value, and you separate the key value pairs with the ampersand character. So you could just keep stacking them up to a certain limit, depending on, I believe there's a limit in the protocol, but I'm not going to go look it up. So essentially our job in this video is to be able to parse out this as well as the subdetails. Now, this is also a moment to take into consideration that this does have different pieces. Unlike, when we're parsing this, we only have one piece of information, or if we're parsing this, we only have one piece of information. We may potentially have two sets of information that we're getting out of the URI. And I think this is a good time to express that by creating a struct. So let's go ahead and do that. Let's create a struct, and let's say a URI data, for lack of a better name. And this initial part here is the resource. So we're going to say resource, and we're going to represent that using a string. Then we have these, which again are key value pairs. So naturally, the way that we would want to represent this. Number one, let's name it query parameters. And we are going to represent this using a hash map or dictionary, depending on what your background language is. Basically, a structure where we have keys and the associated values. So the way we declare that here, we go hash map, and we're going to say string and string. So it's being a little bit lazy. Potentially, maybe this would be a number, this would be something else. But we're going to leave that up to whoever is using this library to parse it based on their knowledge of their own application. We're just going to give it to them as strings. And I think that's fair. And it'll make our lives a little bit easier as we go about implementing this. So we are going to take this, and let's sort of draft up a little mini contract of what we want this to look like. So we can say, we're going to parse our URI data into a struct. And we're going to say let URI data be equal to that URI data. So we want it to be of the type URI data. And we are going to say parse URI data, as we've been doing with all of our other functions that we are creating here. So I'm going to say, let's see if we can generate that. I believe we can. Excellent. It's going to try to give us this statically sized vector, but I don't want to use that. Just want to pass in a reference and then be able to use that. We're going to call this buffer to make our lives a little bit easier. And if you remember from previous videos, we actually did a whole bunch of that pre-processing already, where we were parsing the method or the version here. So I'm going to copy and take a lot of this and recycle it here. Now, basically at this point, everything up to here is great. We're just trying to parse out our first line. We're splitting it up into its pieces. And then from there, we're going to write some unique code. So we're going to delete that. That's fine. So now at this point, we have our parts. Yeah, again, we have two potential situations, and we sort of want to make sure that what we're looking at is a situation that we expect. And what we expect is that the length of this should be either 2 or 3. In most modern cases, it'll be 3, but in order to be, again, that backward compatible, we should be able to handle that there are 2. Anything, if it's 1, 0, anything greater than 3, that's a problem, and we would want to indicate that. So what we're going to do is we're actually going to match against the length of these line parts. And again, we need to be exhaustive, but we're going to handle the first 2 cases here. So if it's 2, we're going to do something. It's 3, we're going to do something. And if it's anything other than 2 or 3, we, at the moment, are going to panic. And say wrong number of parts. All right, cool. Now, this might seem a little bit dumb. And my style for doing this is that I want to be explicit about what it is that we are handling. However, whether we have 2 pieces or 3 pieces, we're going to be pulling out the exact same data here. And as a matter of fact, we want to assign that to a variable. So we're going to say let URI string equal, and we're going to create a block here. Let's go ahead and indent that and close it off. Excellent. So we're going to do, I am going to tell you to ignore that we're not finished yet. Okay, so we are going to take line parts, and we are going to take the second element at index 1. Again, 0-based indexing, so 0, 1. So we're going for the second element here. All right, and we're going to do the same thing in the other case. Okay, cool. We're going to assign that out and then be able to do more processing here. Excellent. Now, at this point, what the contents of this should be is this. And as a matter of fact, let's even take a peek at that and prove it. So let's go print line URI string URI string, and we're going to open up a terminal and run our application. Cargo run release. Excellent. So our URI string at this moment is that. By the way, later on in the future, maybe a different series of videos, I'll go into how to actually use GDB to live debug a running application, but for right now, we're just going to get away with print debugging. It works for our purposes. All right, so we're going to go ahead and comment that out. And what we next want to do is we want to break it down based off of this question mark here. So we're going to go, let's call let resource params vec equal, we're going to go URI string dot split here, and we want to split again on that question mark pattern, and then collect all the pieces of that split. The type of that is going to be vec of and stir. So we're not allocating copies of this. We're just continuing to pass around references of references, which is okay. It's faster, saves memory because everything is very close at this point in the cache of the CPU. So this is very fast. We don't have to allocate anything extra to do this. As a matter of fact, the compiler for Rust may see what we're doing and just shortcut our logic and optimize it anyway, even further. Okay, so all that being said, we now have this. We should assume that this will have two pieces. It'll be a vector of resource params and a question mark and resource params back. Run it again. All right, cool. So we see this is about what we are expecting here. Cool, two pieces. Now, what we care about, and the next bit of processing that we need to do, is if the, well, number one, let's do this. Let's go create a mutable hash map that we can use. So it'll be empty if we don't find anything, and it will populate it if we do. So let's create let mutable query values. Here we go, hash map, string, string, string new. Excellent. If length, remember our language that we're using here. Okay, resource parameter dot length is equal to 2. Then what we're going to do is we're going to do some more processing and we're going to populate this. So the main thing is let's grab our QV string is equal to resource params, the second element of that vector. And we're going to split this into its pieces. And again, what we're splitting on now is the ampersand character. So we're going to say that it's KV pairs equal our QV string split. And we're splitting, once again, on the ampersand character. And collect the pieces of it. And do rec. Ah, thank you. Hash map. Okay. All right, so now we have any number of these, and we're just going to iterate over them. So we are going to see for KV pair in KV pairs dot iterate. It's interesting. You know what? I think I might be able to get away with not doing that. Okay, so we're just cool. I'm going to do that. That's fine. We're going to split this based on the equal sign character. So we're going to do KV pair that KG value vec equal KV pair split equal sign. And at this point, you probably know what I'm going to be typing next. And that's okay. We're going to let it know what the type of this is. Another stir. And great, now we have this. At this point, we can begin populating that hash map by inserting qvalue vec index 0 and qvalue vec index 1. And double check this here. Okay. So this is important. Number one is, we said this is a string. We cannot make it a stir because that's a reference, and potentially the underlying data to that reference would disappear. So instead, in order to make sure that the lifetime of what we need to be putting into this hash map persists, we're going to take this stir type, this reference to a string, and we are going to make it into its own string. So we're going to say dot to string in both of these cases. And what this does is allocate some memory up to the length of this reference. Then it copies the string, well, it copies that data into our newly created and allocated string. This way we have a proper copy, and we don't violate any of our lifetimes. Actually, if I tried to do this wrong, it would blow up on me. If I tried to do stir stir, it would not even let me compile. But some of this is built in as scar tissue or muscle memory from having programmed with Rust so far. Okay, great. So at this point, we actually have all the pieces that we need in order to finish this function. So we go URI data. We can create our struct. Go ahead and populate those fields for me. So for our resource, we have our our resource parameters vec, and we're going to take the first element and we're going to again make that into a string, since right now up here it's just a reference to the underlying string that was being split up. Next, down here, we are going to put in our QV hash map that we created up above. And at this point, we have now finished our function. So let's go ahead, go to the top of this, go to where we are calling it, and let's write some test assertions. So let's say assert equal. We know that this URI data, that the number of parameters should be 2. Should be able to, that should be correct, since we had those two t-value pairs inside of those query strings. Next, we have EQ. We know that the resource itself should be forms, I believe. We'll may write this and we'll go double check that my memory isn't too faulty. So resource, and I believe that should be field forms. Check here, let's go up. Oh, find. Terrible memory here. Okay, find. And again, because this is a type of string, this is just a series. This is a byte string. This is a series of bytes. So I need to convert it into a proper string so that we can do a proper comparison between the left and right. All right, so it's clear that's cargo run release mode, and all of our certs passed. Nothing died, nothing blew up, and no news is good news. So with that, we have finished this function. Now, I'm not completely happy about this, and so in the next video, we're gonna revise some of the behavior, or at least the return type coming out of this function. For example, there are a few different areas where this function might fail, and rather than just blowing up or returning nothing, we're going to utilize the result data type that exists within Rust. So we'll work on that in the next video. Thanks.